Okay, hello everyone. In this stream, I will show you the use of this device. This one. It's called, oh sorry, this one. It's called LinkIt Smart 7688 Duo. It's a device with two sides. There is an Arduino side, like Arduino compatible side, and a Linux side. It's very similar to, or in the way it works, like the Arduino Uno. I will show in this streaming how I used it to drive an LCD, and I explain my project and how you can replicate the project. So basically, all the information you will see here will be available on my project page on Axter.io. I will link the project in the description of this video later. Okay, basically this is the current state of the circuit, and as you can see, there are just 3 components, and the device is here. I try to show you. It's connected to the, oh sorry, it's connected with a breadboard. Okay, and my project right now, it connects to Heroku, and ask to the Heroku platform some information to an application I made, and it asks from the Heroku platform how is the status of my deployed application, and in the LCD I will show the two of this information. Okay, so basically you have to buy one of these device. It's very cheap. It's $16, and so you have to connect these two devices with this like in this schematic, and once you have done this, you have to set up the device. And first time you connect to the device, it will show you like just on a Wi-Fi hotspot. So you just to search for the Wi-Fi with the Wi-Fi from your web from your computer, connect to the device, and open the browser to this address. Then it will ask you to set up a password. Set a password for the root account, and once you have done, it will show you some information about the current configuration. When you have finished to configure the first part of the device, it's better to press on network, And so let's see here. And on network, you can select to change from AP mode, access point mode, to station mode, and there you will be able to search for your local access point, your home access point, set up the access point password, and once you have done it, you can configure and restart. Once you have done it, the board will be not more available as access point, but it will be connected to your network. And then you are able to connect the device through SSH. So, but before that, I will show you how to configure the Arduino side. So, as I said, there are two sides of this board. The Linux side is available through SSH, and the Arduino side is easy to configure. Just you can just use the Arduino IDE, but you have to download the the library for the to to make it compatible to the Arduino IDE. So you have to go to preferences. Okay, try to resize the screen. Sorry. But I can't. So you have to go to preferences, and then it will show you this screen, and here additional board managers URL. You have to add this one. I will. Oh, sorry. Just a minute, please. Okay, you have just to add this one, this address. Once you have done it, you press OK, then go to in the menu. There is tools, and once you select board, there is board manager, and here you can select search for, just wait for the update, and then smart link, no sorry, LinkIt. Okay, just search for LinkIt, press select it and click install, then restart the Arduino IDE, and the board should be available from the board, and connect the device. And there is this code I just explain rapidly. This code is compatible with Arduino Liquid Crystal library. So there is an example in the Arduino examples. So at the beginning, I just tried to write on the LCD and test the connection with the example. And you can find the example in file, examples, and search for let's see, where is it? I don't remember. Okay, display. No, display is not. Liquid crystal. Okay, it's here. Hello world, and you will have this code here, and it basically print hello world on the LCD just to change the lines. No, you just have to do. Okay, it will show hello world on the first line of the LCD. So come back to my code. I tried to make it more general as possible, because I wanted to have the flexibility to change the less possible the Arduino side. So I have an array of string. It's called list. Okay, it's not a good name, but in the setup we set up the bridge, and I will explain later what is bridge. And then I set up the LHD begin. It's a 16 and 16 characters, 2 lines LCD. And then on the first line I will print loading. Then I will clean all the string, and then I start with the bridge. So the board is able to, the Arduino side of the board is able to communicate with the Linux side. And for example, like in this example, it's possible to launch a command in the Arduino side and wait till the end of the execution, and then grab the output of the command on the Linux side. In the Linux side, it's not the case of this streaming, but you can call some library that are able to manage the hardware of the Arduino side. So in this example, I just call the Python, and then they send the path to my script on the Linux side. And then I said run, set up it and run. And then I said until I have information, so if until there is some data available. So basically what it's happening is here is the application run, and until there is an output, so it's alive, the process, I will read the output, and on each line read I increase a counter, and if I reach the max line possible for my Arduino side, I break it. If not a new line and it's another character, I temporarily save the information. So basically I have an array of a list of string, and on each line there is the first 16 characters of, no, there is the output of each line with the max number of line is max line, that is 16. Yeah, so I'm just buffering the output, and once done, and it will take just 5-6 seconds, I don't think, no more. I will print the 2 lines at times to the LCD. So I read all for 10 times. It's configurable, but for 10 times I read each line two lines at times, as you can see here also, and I print the first line, I read in the first line, and the second in the second line. Okay, and then I wait 30 seconds, and then again, and again, and again, and again. Okay, so this is the Arduino side. So whatever you print, you do in this script, the output of the script will be shown on the LCD. So once you have done this, just to verify the code, and if it's all okay, you can send it to the device, pressing upload. Okay, it's okay, and I compile it just to make it okay. Now it's uploading on the device. Okay, right now we have done with the Arduino side. let's see how to write the code for the Linux side. So from a Linux terminal or Windows with PuTTY or whatever with a SSH client, also okay, you can go. This is the Arduino, the Linux side of the board, and there is this directory IoT. So here I created this directory. Permissions. It's Heroku. Okay, Heroku. And then I created the service.p, and to create it I just did vi the service.p, and then if you press E and with the mouse you press paste, you can paste the code. So you can grab the code from the web page on axter.io, my project. It will be available in the description, and then paste here all the code. Just press I and then paste the code with the mouse, and once you have done, you can do ask then q.wq, and you will save the file like this. So I will remove the file. Or if you don't want to do something like this, you can use a software like FileZilla or another WinSHP, and create the file on your computer and then transfer the file on the board using the root account you set up at the beginning. Okay, so let's see just the script. Well, not found. Okay. So basically, what I do here is, this is my app. Okay, I have just to change my script a bit. This is my app, and there is this information was found on the Heroku webpage. Let's see, Heroku platform API. So I went here, and here you can find platform API reference, and here it explains how can you make some requests to the Heroku platform for your application. For example, if you want to know if it's up, if it's running, if it's in maintenance or not, the usage rate limit, and so on. And what I decided to see, I wanted to just see the app and personally I was interested to update it at and release it at. So I want to remember to see every time on my desktop when the application is released and when it's updated. But you can of course see other field. You have just to change the code. For example, maintenance. It's interesting, and other stuff. And here it will show you how to make the requests and how the format is, how is it the format of the answer. So basically we have done the same things with Python, and here, so I connected to my application, and then I added an header, HTTP header, and then in the authorization I add the token. So how you can have the token? You have to set up. So if you have Heroku installed on your computer and you have, sorry, I continually to, okay, if you have a Heroku and you are just use the Heroku configure on your PC. You have Heroku, this one, and it will show. If you say Heroku token, it will show the token of your application, current application, if you have one. And so you have to write this one to show the token, grab that string and put it here. I had created a file, a new file called the conf.py, and inside it there is a variable. It's like this. It's like conf.py, and I just wrote here you have to copy the token, okay, and then in the same directory of your on the Linux side. So here, let's go on, and here the script to make the request, and all the request, the response of the request is copied inside the content variable, and then it's parsed as a JSON, and then I grab two data, release that, update that, and I remove the first two characters of the fields because I was not interested of the here. As you can see, this is the format of the response, and then I remove 20, and then I print release that and print the variable real at, and then replace the t inside the string with a blank, and the same is done for updated at. And that's it. And once you have done, you just have to save the script. As you can see, I try to show you the code, the application running. Okay. Okay, as you can see, there is this is the board with the code running. Okay, if I add more time, okay, as you can see, switch it to release that and continually to do it 10 times, and then try makes the request again. And you can use the same code to just change this one. For example, you can create let's try to for a second to move. Okay, I just plug it off this device, but I have to change the script before. Okay, let's see, for example, if we want to show a message. Wait, that device will come up. It takes a while to go up. The root host is down. Come on, baby. Come on, baby. Okay, it's up again. Then let's try to connect again. Go to IoT Iwaku. Move service to Iwaku service.py. P service P y and print hello, print false, print LinkIt Smart, print 7682. Okay, save it and exit. Oh no, the name was wrong. Service. Service.py, and then reboot, or we can just reboot the Arduino side. There are three buttons on this the board near the USB, and the first one is for Wi-Fi reset, one is for Linux side reset, and the third is for the Arduino side reset. So there is some errors, but I will show you what's happening. Oh, come on. Hello, folks. Well, because there is a loading LinkIt Smart 76882. Okay, and that's it. So if you want to change the application, you just have to create another script like this one and do whatever you want. If you want to see the Bitcoin price or the weather forecast, Facebook, the like on your Facebook page, and so on. Thanks for watching it, and see you next time. Bye.